Let's start the meeting. As you know, this meeting is recorded and will be uploaded to public internet. So chances are whatever you say remains forever somewhere. With that, let's start the meeting. We have quite a few items on the agenda. People have already added a few. So instead of me giving an update, I'll let people to start. So I don't know if Connor is today. I don't see him right now yet. Connor Doyle from Intel has a proof of concept for simulating large clusters to test the scheduler scenarios. If he joins, we will have a demo from him.
Hey, he just showed up in Slack. Hi, this is Mario. Connor just said that he couldn't join.
Okay.
And I pasted the right Zoom URL because there was some confusion between documents and Slack info in the channel topic, etc.
Okay. So Connor just joined actually. So, but anyway, sorry. My computer apparently was my computer speaker was very low. I didn't hear what you said in the first few seconds when you started speaking. So did you say that Connor was not able to join, or?
Yeah, exactly. Connor wasn't able to find the right URL, it seems. So was I. And I pasted the right one into a thread where he appeared. So I expect him to join soon.
Yeah, he's here. Connor, hi, Connor. So hey. Connor, you have added the first item of the agenda. So I let you take it over if you want to tell us what this proof of concept is. And if you want to have a demo, we are here to see and listen.
Okay, great. Yeah, so I just wanted to talk about simulated kubelet cluster, basically for the purposes of testing scheduler policies. And so, the background is in our group at Intel, we're working on some scheduler plugins and also working to test, some gang scheduling on top of the new permit plugin. That's Ajay will talk about that next, I guess. So next topic. But we had the need for a simulated environment for a scheduler, and around the same time we started working on it, somebody started asking around in the Slack channel for about the same thing, and so we figured we would try to present it and see if there's broader interest, and
Sure.
just talk about what we did.
Yeah, sounds great.
Yeah, so I can share my screen and do a tiny demo. Oh, hey, Marianne.
Yeah, great that you're doing this.
Yeah, so, oops, yeah. So this thing, we call it notice ponents. it's a terrible pun, but basically the idea is that you set up the fake cluster, and then you can run a scenario that basically asserts basic facts about what kind of nodes are in the cluster, what kind of pods are running, what phases they're in. You can move pods along in the pod lifecycle, and then you can kind of do more assertions based on that. And so, kind of broad strokes, we're relying on Docker Compose to provide the Kubernetes control plane. So I've already launched that. So we've got etcd, the Kubernetes API, and the stock scheduler are running. And then the other part is
one quick question. You run everything locally, right?
Yeah, right now. So the two binaries that we built take in a kube config as input. So technically you could run it against a real cluster, but we just provide a make target that builds a kube config that points at the local cluster.
That's actually more valuable. To be able to run everything locally is more valuable, because in a lot of test scenarios you want to run things locally as opposed to like in a bigger cluster. And of course, for a and sort of like node simulator where you want to simulate a large cluster. You don't want to spend a ton of money on running real clusters with real nodes.
Yeah. So with this, we've tried up to I think 256 nodes. We had some issues with API rate limiting. I think we can get around that just with some config, but you should be able to easily do thousands on a single machine for free.
Oh, wow, that's great. Yeah.
So basically, there's three kinds of config files that drive this thing. The first one is kind of describing what classes of nodes are in your node pool, and so they're just named. So we've got two classes here. There's a large and a small. One has 8 CPUs and 128 gigs of RAM, and the other one has 2 CPUs and 8 gigs of RAM. And then there are some pods that you can refer to in your test scenario. And so here we just have two kinds defined, a 4 CPU pod and a 1 CPU pod. These can have any content whatsoever. The container doesn't really matter because it never ends up executing, but it just needs to parse as a pod spec. The main thing is the resources and the name, right? And then this is, I think, the coolest part, the scheduling scenario. So we started out writing a big, complicated YAML spec. And then when I was commenting the YAML, I was like, these comments look parsable. And so we decided to try it out, and it actually works pretty well. So there's a small grammar. You can do 4 kinds of steps. You can assert things, create, change, or delete. And right now you can talk about pods and nodes basically. And so you can create 1 large node, create 2 small nodes, assert that they're running, make a pod. You've got timeouts kind of included in your assertions. Yeah, that's pretty much how it works. I think probably the most exciting thing at this point would just be to run it. So, basically we've got 2 binaries. npsim is just the node pool simulator. And so if you want to run some manual tests, you can just fire this up. And then you've got a fake cluster with a bunch of fake nodes, and then you can kind of test and probe at your patch scheduler and see if things are working properly. The more complete version is the np test. Oops. And this thing is the one that takes the pod config and the scenario config along with the node configuration. So you can see we've got a namespace flag. You can run this inside a namespace if you want to. Whether it passes or fails, it cleans up after itself, which is kind of nice. And then you can kind of see the flags to configure which kubelet to talk to. By default, it just looks at kconfig in the local directory. And you can see that's just pointing at my Docker Compose machine. All right, so this is what it looks like. We're just pointing at those 3 files that I already showed you and pointing at the default cluster. So it runs kind of fast. It's kind of anticlimactic, but I think it's kind of fun just to see what happens. So yeah, completed all the steps and exited 0. So ta-da. It's kind of fun. I think next steps, we'd like to make this easier to use as a library so that you could include this from your, sorry, did it drop out for a second? No, okay. Yeah, we'd like to make this usable as a library so that if you have like a repo where you're developing like a scheduler plugin, you could, do your testing there and just have everything run in CI instead of having to deal with the binaries that we build necessarily. But yeah, this project is only like 8 days old or something like that. So just kind of looking for feedback right now.
Oh, that's actually, this is actually great. I really like the idea, and also the way that you implemented it with the expectation and how to basically write the expectations and all. It's seems pretty easy to use. It would be great if you can add. Do you have like a GitHub repository for this? I assume you do, right?
We do, but it's not public right now. We started the process to do that, but it takes a little bit. We have to get through a little bit of legal compliance, but something we've done before.
Yeah. But yeah, once it's available, it'll be great if you can give us some more information about like the links and possibility of using it, as you said, like a library for more testing. Especially if this is useful for testing larger cluster scenarios. I don't know if you can probably add like performance metrics to it as well for testing performance too. That would be very valuable as well.
Yeah, that was one thing we had planned, was maybe to build like just a summary, like output an HTML file that has like a dump of what happened throughout the scenario, something like that.
Yeah.
Maybe collecting the Prometheus metrics from the scheduler during the run, perhaps too.
Hi, just wanted to pop in. This is Jonathan. A couple of comments on sort of that topic. So there was from I think the SIG test team, they came up with a really interesting way to run their conformance tests with the profiler turned on. That could be probably used here, and we could get CPU profiles out of the scheduler from these scenarios, which would be pretty neat.
Yeah.
At least for like core scheduler development. And then the other thing in terms of you're using Docker Compose. I don't know if you've seen Kubernetes in Docker, KND, and I'm not sure how suited that is to your application, but it might be something to look into.
Okay.
Is it called KND?
KIND, kind. Kubernetes and Docker.
Yeah.
Okay.
I have one question. It seems you simulated the multiple nodes, right? So I'm assuming that you're not running a real kubelet or simplified kubelet, just instead of just inject one node API object to the API server. Is that right?
Yeah, that's right. Actually, I have the world's most hacky diagram.
Yeah, I think that's the right direction. If you run a real kubelet, that will be.
So let me just share this. There. All right, can you see this? It's like,
yes.
So right now it's basically, Docker Compose is running these those 4 components, and then npsim and nptest are running on the host, and they're consulting those config files and just talking to the API server. And so, like, if you're just running npsim, which is just the fake node pool, all it does is it registers as like, however many nodes you configured, and then when the scheduler binds a pod to that node, we have, excuse me, it reports, it reports back that the pod is running. So, since the kubelet only ever knows about pods in the end, it should work for testing other stuff too, like controller manager and job runner and things like that. You can also, one thing that we implemented was, you can basically drive the runtime duration and the final phase of the pod just through labels. So it's like np dot runtime or something like that. You just give it a duration, and then the fake kubelet will wait that long before reporting the final status. So.
Okay, that's great. Yeah, thank you very much. Are there other questions?
Yeah, I also have a question. Could you please show the node spec again, or the fake node spec?
Yeah, one second.
Sure. Sorry, I actually meant the pod spec, the workloads. Oh. Excuse me. Okay. So, there are no requests. So I was wondering, what does the scheduler actually schedule based on? You're setting limits,
So,
but not requests.
yeah, the API server automatically sets request equal to limit when you only set limits. So
okay.
it's just shorthand.
Yeah. Okay. Makes sense.
Yeah.
Yeah. I was wondering, so what I had in mind was something that would use just standard pod manifests, which I could pretty much export from a running cluster. But that should be easily translatable into the format you have here, right? So
yeah,
it would be a simple job.
Yeah, so one of the challenges coming up is probably, if we want to talk about the higher level abstractions like jobs and deployments and daemon sets and stuff like that, it would kind of, in the current design, it would add a kind of an explosion in terms of the config parsing we have to do and the specific resource handling in the interpreter. And so we're trying to think of a generic way to, just talk about like arbitrary Kubernetes resources. Maybe you just point at a YAML file or something like that, like create for, foo.yamls or whatever. But we haven't really explored that yet.
So we have also discussed like maybe using this higher level abstraction outside of node response, like create a job outside of node opponents, and node opponents only handles pods. That is something we can do as well. Or use other abstractions like, this is only specific to gang scheduling, but there is pod group abstraction in gang scheduling. You can talk about a group of pods. So those are the possible options, but yeah, as Connor said, like we're still exploring it.
All right.
Actually, I have a couple of questions related to this. So Connor, have you looked at something called scheduler perf within the Kubernetes repo? This is something
for a while. Yeah. It's been a while since I looked at that thing.
Yeah. So is the scope of the project limited only to the scheduler performance, or is it for other components too, like API server and HCD or any other control plane component?
Yeah. So our use cases were mostly around just new functionality in the scheduler, in particular, kind of testing some scheduler extensions that we're trying out. We hadn't thought about performance necessarily, but I guess that would be kind of a next step or another use case for this.
Yeah.
Okay. And say if I want to change the policy in the, not the policy, but say if I want to change the predicates or priorities associated with scheduler, is there any config file where I could change?
So yeah, right now the Docker Compose YAML is kind of, I guess what you could just modify that manually. It's not the nicest thing, but it would probably work. I can just show you that one real quick. But actually, in Ajay's demo, which is coming up next, he used this project to test the permit plugin for gang scheduling. So he can talk about how he turned off the default scheduler and used the patched scheduler that he built on his own machine.
Let's go to that demo because we don't have a whole lot of time.
Yep.
There are already a couple other items on the agenda. So we can have follow-up questions if people want to stay, but let's get to the main meat of the meeting and the time that we have. So Ajay, we are ready for your demo.
Cool, thanks. So let me share a quick presentation I had. All right. Is it?
Yeah, we can see your screen.
Cool. So I'm going to talk about so we kind of implemented the permit extension point that was proposed in the KEB for extending the schedulers.
Right.
So before that, let me just talk about a bit about the current state. So currently we have the single scheduling loop, which looks at the pod and it considers one pod at a time, goes to the priorities, predicates, and assigns the pod to the node. So the main motivation for us was that like we wanted to do gang scheduling, and there's currently no way to do it. There are external products like Kubebatch, but what we contend is that using just a permit plugin, we can say that at the admission time of a pod, we can allow, we can admit only those pods, not at the admission time, but at in the scheduler, we can only allow those pods which in a gang, like for example, if we have a pod in a gang, we allow only those pods for when all the pods in the gang have been assigned a node, basically. So maybe I can show it, which would make it clear. So in the designs, what we have is the permit would either allow a pod or reject a pod or wait with a specific timeout. So to that effect, we just have 3 interfaces or interface methods, should accept, should reject, or should wait for the pod. So for example, this is the flow of the single loop. In the concurrent loop filters the pod, scores the pod, and so on. And when we have the asynchronous loop, which binds the pod, we go through all the permit plugins and then see that should accept that particular pod, wait for it, or just reject that pod. So if we zoom in a little bit, what we can have is a permit plugin running an infinite loop and just checking if checking if it should reject, should wait, or should accept the pod, and then the accept and reject would be the terminal states, and if it is a timeout, then it would also reject. So if we see that for an example for gang scheduling, what it mean is let's say we have 4 pods in a gang, and then if any one pod has been rejected, then you just see that one pod has been rejected, so we should just reject this pod and then not let it bind. And let's say if we have 2 pods in the gang and 2 pods have been seen by the scheduler and 2 pods have not yet been seen in a gang of 4, then basically we need to wait for it with the timeout. And then if none of that is true, especially in the case of a gang, we just accept it. And I've used
so can I just make sure I understand here? So what you're trying to outline here is a scheme by which the scheduler still schedules one pod at a time, but with this permit extension, a gang gets held up until the scheduler has scheduled all the individuals in the gang.
Right, that's right.
Thank you.
So that's right. So in fact, in that KEP proposal that we have basically for the framework, for the scheduling framework, we have this example there. You can look at that if you want to get more information. So anyway, go ahead, Ajay.
Cool, thanks. So I've used one of the scenarios that I'm going to show in a bit, and from node exponents that Connor just showed. So basically, I'm creating 3 nodes or 2 node pools, one having 8 CPUs and 2 nodes having 2 CPUs each. So that's basically 12 total CPUs. And I'm trying to schedule 2 gangs, one gang having 2 pods requesting 4 CPUs and the other having 6 pods and requesting 1 CPU. So basically it's requesting a total of 14 CPUs and we have 12 available. So, and what I'm asserting is that one gang, while one gang is running, all the other pods in the other gang are waiting. So it's if we didn't have the gang scheduling plugin, in that case, 4 of the 6 pods, for example, would run and 2 pods would be pending. But if we have the gang, then all 6 should run, all 6 should be pending while the other 2 are running.
So what prevents this system from getting the situation in your example where the first gang has gotten 7 of its pods scheduled and the second gang has gotten 5 of its pods scheduled and then nothing else happens?
So that's a permit plugin basically. Essentially, the permit plugin does not allow all these pods, does not allow any of the pods to get bound to any of the nodes before all of them pass the scheduler. Basically, to get to
right.
Right.
Well, what I'm missing here is the relationship between the gangs. I understand the permit plugin is going to work on each gang independently, right?
There's no relationship, if I understand correctly, there is no relationship between these two gangs. It's just each one of them is a gang of its own.
I think I understand the question, because even though the pods are not running, have not been bound, they've gone through the reserve phase.
Yes.
So from the scheduler's perspective, you could have, you know, n-1 reserved, and then we use that when making the scheduling decision for the others n-1 getting reserved. So the scheduler itself could get into sort of a resource deadlock that way.
Right. Let me elaborate my question.
Yeah, so there's a timeout, right?
Yes.
Yeah, there is a timeout.
Just to make sure, clear. Warm-up question, right? The scheduler doesn't understand the gangs, and it can work on these pods in any order, right? We've got 14 pods here. It might happen to work on 7 pods from the first gang and 5 pods on the second gang before it finishes either gang, right?
Yes.
And in that case, all right, in that case, it's at that point it's run out of resources. It can't do anything. So the system will sit idle until the timeout happens.
That is correct.
That's correct.
Thank you.
But I mean, so the guarantee that this permit plugin gives is that the gangs will be scheduled, the pods in the gang will be scheduled together. However, the ordering of which gang scheduled first is not deterministic. That's the whole point here. The gangs will be scheduled, but in which order?
Right, but the problem, actually, I'm pointing out is the scheduler doesn't work on gangs; it works on individual pods.
Yes. I know there might be resource deadlocks, but eventually it'll be resolved.
So the timeout will eventually resolve things. You get into weird situations if you have the 2 timeouts expiring at the same time. I think perhaps a more efficient solution would be that the gang permit plugin should try to detect and short circuit some of these scenarios.
Maybe.
Right. That would be one of the optimizations.
Yeah. I can jump into the demo.
Sure.
So what I have here is, ran this before. So I'm using no response, what Connor showed, and basically not running the scheduler, but running the controller manager and the API server. And I'm just like compiling the binary and scheduler binary and then pointing it to the API server that's running basically. So let me show you the scenario. So basically, like what I said, I'm creating 2 node pools and then creating a 2 CPU 4 gang and 1 CPU 6 gang, and then asserting things for it. Like first, like asserting that 4 pods are running, and then the other 6 pods are waiting, and then the other after that the remaining 6 pods are running. So if this should also be pretty quick, but I can try to highlight when it's there. So basically it creates the 3 nodes and then it should make the first 4 running while the 6 are waiting, while even though 2 should have a reservation, or 4 should have a reservation. And then once they are succeeded, the remaining 6 should basically run.
Yeah. Nice. That's neat.
And that's about it.
Yeah, thank you very much. That was encouraging, at least, to verify that some of our functionalities and design works. One quick update regarding the framework. As you know, or I don't know, maybe you don't know, we have had a revision for the CAP, which is already managed a few weeks ago. It was managed like maybe over a month ago. I don't remember exactly when it was. But anyway, I have a new change, new PR basically that I'm going to send out soon based on this new changes and new ideas. So it's going to change some of the interfaces that we have for the plugins. Hopefully it will make things cleaner and will make it a little easier to create these plugins and start the scheduler with custom plugins. I will send that out hopefully this week. I'll send a PR hopefully this week, and then I will start filing a lot more issues for building all the extension points in the scheduler.
Cool.
We're already out of time, but yes, Yassine, do you want to? Please feel free to leave if you have other things to do. We are going to continue since we have other items on the agenda. Yassine, you have some updates for us?
Yes, basically it's around adding scheduling constraints to the runtime class API. Just wanted to highlight some of the latest improvements. Basically, we're asking if we should build native predicates on the scheduler to filter the nodes out based on if they are able to handle a specific runtime class. But since the runtime class is based on basically toleration and node selectors terms, basically if we go down the path of native predicates, it would be composing the toleration predicates and the affinity predicates. So it raises question about how we handle composition between predicates on the scheduler. So this is the first issue with this cap. The second one is if we do not go down the path of building a native runtime class predicate, and we go down the path of having an admission controller that takes the topology information on the runtime class and add it to the pod spec, we have a user experience issue, as you highlighted, Bobby. Basically, the user have no idea about why his pod is not bound to a node. So we do have to balance between the user experience problem and the composition problem, knowing that if we start to compose predicates, how do we handle like opt-in, opt-out of the composed predicates or things like that. I don't know if you folks have any thoughts about this.
I haven't thought very carefully about the implementation of the runtime class predicate, but I feel if we don't want to have that user experience issue that basically I pointed out and I kept, we should probably go with a separate predicate for runtime class. One option that we have here is that we can build a library for like node selector predicate and also for toleration predicate, so that both the actual node selector and toleration as well as the runtime class predicate can use. We are going to do some amount of basically maybe reprocessing of certain node selector rules in the case that we have both runtime class as well as a node selector in the pod spec. In those cases, I think it should generally be fine. I don't expect to see much of performance difference between like combining everything into a single predicate versus running them in separate predicates. So I still feel like with having a library, we can implement this cleanly without much performance penalty, and also it gives us better user experience, because if we have a separate predicate, then we can, if the predicate fails, we can show user what happened. For example, say this many nodes didn't match the runtime class that you requested for your pod.
Yes, and basically, I think that it would happen whenever we have any scheduling constraints on another resource other than a pod. So it might happen today with a runtime class, but tomorrow it would happen pretty probably with any other resource.
Right.
So I think that going down the path of the library is fine, but I don't know if we could have any repos or something that could be scheduler specific, like under Kubernetes 6 or something like that?
For what? I'm not so sure if I understand.
Well, do you want to build the library in tree or out of tree?
It should be in tree. It can be like basically the library is just probably a bunch of functions. They can stay in the same directory as other predicates.
Okay, that's fine.
All right, we are 8 minutes over time, but if you have more questions or comments, please share with us.
Hi, Bobby. This is Sudesh. I had a question for you. So last time that you told me to make the cap, but I just was not aware of the process. Like, should we start working on the PR before the cap is merged, or should we wait for the cap to be merged?
Actually, the way that the newer process is like this, we start with a cap. The cap must be merged, and usually the deadline for merging these caps is a lot earlier than our actual code freeze. So it makes more sense to first merge the cap and then work on the PRs and then merge the PRs, right? So that should be the workflow.
Okay. So I think the last thing that happened was like addressed a comment. So maybe if you could review that.
Yeah, absolutely. Sorry if I'm not very I'm not very on time on giving you guys a review. I usually get a lot of reviews among other things, so I sometimes cannot provide a very timely review.
Yeah, no problem.
All right. Any other questions?
Yeah, just quick update on the cap of even part distribution. So I think some general directions we are both fine on we are using a separate predicate and separate API spec to describe those kind of information. And some corner cases also have been discussed, especially on the max SKU. I'll add a specific section on describing that. So next step is to having some API machinery experts to reviewing the API spec. Then, yeah, hope we can merge that soon.
Yeah, well, sounds great. Thank you very much for your help. I haven't seen your most recent changes, but I will go ahead and review the cap. Hopefully we can merge it soon, and then we can start working on the implementation as well.
Sure.
Sounds great. Thank you. Any other questions, comments? Going once, twice. And thank you very much, Valerie, for your help with the non-preempting priority and the work on that. So that one is one of our items as well. We are gonna have that in 115 too. All right.
Thanks. As far as I know, that's all being passed off right now.
Okay. Thanks. All right. Thank you very much. I'll see some of you folks next week.
Okay.
Bye.
Thank you.